Hello and welcome to this compound interest revision lesson. So we've got 3 starter questions here. So pause the video and have a go with these questions without a calculator, okay? Best of luck. Okay, so to go through the answers quickly, if we want to find 15% of 360, if you don't have a calculator, you can't just times it by 0.15. So we're going to have to find smaller, easier percentages of it. So I know that to get 15%, I can do 10% plus 5%. And that will be equal to 15%. So 10% of 360, well, that's just 360 divided by 10, so that's going to be 36. And 5% of 360, well, 5% is half of 10%, so 5% is going to be half of 10%, which will be 18. So now I know that 10% of 360 is 36, so I can pop that there. And 5% is 18, pop that there. 36 plus 18, that is 54. So 54 is equal to, 54 is 15% of 360. There you go. Now for the next one, we need to share £56 into the ratio 5:3. Okay, so if you've got the ratio 5:3, that means the total parts is 5 plus 3, which is equal to 8. So we're looking at 8 different parts. That's what we need to split 56 into. So 56 pounds divided by 8 equals 7 pounds. And this 7 pounds is equal to 1 part now. Okay? So if we want it in the ratio 5:3, we need to times each of these numbers by 7. So 5 times 7 is equal to 35 pounds. And 3 times, chucking pounds in there, 3 times 7 pounds is equal to 21 pounds. So splitting £56 in the ratio 5:3, you would get 35 and 21 pounds. Okay, and the last one now, 0.4 times 0.7 equals, well, let's not deal with decimals, let's deal with whole numbers. So if I wanted to do 4, and I want to do times 7, but how did I get these numbers? Well, 0.4 times 10 is 4, and 0.7 times 10 is 7. 4 times 7 is equal to 28. Now, because I multiplied by 10, I had to multiply 0.4 by 10 and 0.7 by 10. That means if 4 times 7 is 28, that means 0.4 times 0.7, that means I have to divide this 28 by 100. Because I timed 0.4 and 0.7 essentially by 100. I need to divide it by 100 to get the answer to my original question, which is 0.28. So very well done if you got those 3 starter questions right, okay? So let's jump into the main lesson now. So Noddy words for today is to be able to perform repeated percentage change, and the maths watch clip is 166 for those interested. So just a quick recap. So with compound interest, we're using something called multipliers, and these are numbers that we can multiply another number by to easily calculate a percentage increase or decrease. So if I wanted to increase something by 10%, what would I have to multiply that number by? Well, an increase of 10% is the same as saying 100% plus 10%, which is equal to 110%. But multipliers are the numbers with decimals. So we now need to turn this 110% into a decimal. How do we turn percentages into decimals? Well, we divide it by 100. So 110% divided by 100, that will give us 1.1. So if you want to increase something by 100, if you want to increase something by 10%, your multiplier will be 1.1. Okay? Another example, if I wanted to increase something by 30%, well, that's the same as 100%. Because we're increasing, we're going to add 30%, which is 130%. Now, if we want to change this into a decimal, because multipliers are always decimals, again, convert a percentage to a decimal, divide it by 100, and that will give you 1.3. So if you want to increase something by 30%, you multiply it by 1.3. Okay? And then on the other side, if you think about decreases, so if I want to decrease something by 5%, so I've got my original 100%, and to decrease is to take away. So I'm going to take away 5%. 100% take away 5% is 95%. Now, to turn this to a multiplier, I need to turn this into a decimal. So again, I'm just going to divide it by 100. 95 divided by 100 is 0.95. So if I wanted to decrease something by 5%, I would multiply it by 0.95. Okay. And then last one, if I want to decrease something by 15%, well, again, decrease means to take away. So 100% take away 15% is equal to 85%. And again, now multipliers are always decimals, so I need to divide this by 100. 85 divided by 100 is 0.85. So if I want to divide something by, if I want to decrease something by 15%, sorry, all I have to do is multiply it by 0.85. Okay? So it's a quick warm-up task for you now. So you need to write the multiplier to show an increase of the following percentages. Okay? So pause the video and try and calculate what multipliers you would have to use to calculate increases of the first three ones. And then the next three are going to be decreases. Okay, so pause the video and have a go. Okay, so the first one, for A, your multiplier would be multiplied by 1.25, an increase of 25%. For B, it would be a multiplier of 1.13. And for C, it would be a multiplier of 1.04. Okay, because remember, 4 divided by 100 would be 0.4. Okay, so therefore 104 divided by 100 would be 1.04. Okay, and for the second one, a decrease of 25% would be times by 0.75. 100 take away 25 is 75% divided by 100. A decrease of 13% would be a multiplier of 0.87, again following the same method. And for a decrease of 4%, you would divide by 0.96. Okay, so just a quick little warm-up task. Now we can jump into the main lesson now. So if I have £500 of savings in a bank account, and these are going to increase by 20% every year for 5 years, how much money do I have after 5 years? Well, there's two ways of doing this. There's the long way and the short way. But just to remind you of the long way, just to help you realize why we use the short way. So we've got £500, and it increases every year by 20%. And we're going to figure out what the number is after 5 years, okay? So I've got 500. If I want to increase it by 20%, my multiplier is going to be 1.2. Okay, so this is the first year. Oh, hello, sorry. So this is the first year. So 500 times 1.2 is equal to £600. And then the second year, because it increases by 20% of the new amount now, so it's going to be 600 times 1.2, and that is going to be £720 we now have after the second year. And then after the third year, 720 times 1.2 is equal to £864. And then the fourth year, we have got £864 times 1.2, and that is equal to £1,036.80. And then the fifth year, we have got £1,036.80 times 1.2 is equal to 1,244 and not comma and 16 pence. Okay, So after 5 years, we've multiplied each new number in the bank account by 1.2. We've increased it by 20%, and we end up with £1,244.16. Now, there is a much, much, much easier way to do this, okay? Because if you think about it, all we're doing, what we've really done is £500 times 1.2 5 times. That's all we've done. Sure, we've rewritten the numbers, but that's all we've been doing, just timesing £500 by 1.2. So a slightly shorter way of writing this would be £500 times 1.2 times 1.2 times 1.2 times 1.2 times 1.2. And if you type that into your calculator, you would get £1,244.16. But there's an even easier way of writing this out. Okay, so it's a slightly less long-winded way, but there's an even easier way, and that would just be £500 times 1.2, and because we're times it by 1.25 times, we put 1.2 to the power of 5. And double check this for yourself. Get your calculators. 500 times 1.2 to the power of 5. And there you go. There you have it. Same as always, £1,244.16. We've still got the same answer. Okay, we've done 3 different methods. I'm sure you'll agree this last one we've done here is by far the best. Okay, and all we've done there, the formula we use for this, the compound interest formula, is our original amount times by the multiplier to the power of number of years. Okay. In the case of compound interest, it'll always be things worked out every year, but just double check the question, because this number of years, it could sometimes be interest is added monthly. Okay, so just take care when you're reading the question. But for most compound interest questions, it's all based on the number of years. Okay, so it's your original amount times by the multiplier, and that multiplier is to the power of however many years you are saving your money. Okay, so let's do another example now. So £700 savings increased by 15% every 3 years. Every year for 3 years. How much do I have after 3 years? So let's just remember the formula quickly. So it's the original amount times by the multiplier to the power of number of years. Just put that in a box just to remind you that it's the power of, okay? So let's take the numbers. So the original amount is £700. The multiplier, well, we're increasing by 15%. So just take a moment. So multiplier. So it's an increase of 15%. So 100% plus 15% is equal to 115%, which would be a multiplier of 1.15. Okay, because that's 115 divided by 100. So multiplier of 1.15, and we're doing this for every year for 3 years. That's going to be 1.15 to the power of 3. Get your calculator. 700 times 1.15 to the power of 3, and you should get 1,064.61 pence. So be careful. Make sure you're rounding up correctly. So when we're dealing with money, we always round to 2 decimal places. Okay, so just be careful of that. And if you really want to double check that, do it the long-winded way, and hopefully you get the same answer. If you did the shorter way is the easiest way to make sure you got the right answer. Okay, because if you do the long way, it's very easy to type a number in slightly wrong. Okay, so these questions we had amounts of money, and we were increasing the money as we gained interest. Okay, so the key word in these questions was increases. But the next part of these questions, or the next 2 examples, are going to be decreases. Okay, so it's really important just to make sure you double read the question, whether you're calculating an increase or a decrease. Okay, so next example coming up. Now, these questions, so if we have a car, if we buy a car for £1,000 and the word depreciates, it basically means there's a decrease, okay? So if something depreciates, it basically means it decreases. When you buy a car, the minute you take it off the drive, that car is worth less than you bought it 10 minutes ago, okay? And that's just called depreciation. So everything depreciates, it loses value over time. So in this case, we've got a £1,000 car and it depreciates by 10% every year. So what will a car be worth in 3 years' time? Well, let's look at our formula again. So it's our original amount. We're going to multiply that by our multiplier. And that is going to be to the power, have I got enough space? Number of years. Perfect. Okay, so we're going to use the exact same formula. So off we go. So the original amount is £1,000 because it's £1,000 car. Now remember, the key word is it's depreciating, it's decreasing in value. So what's the multiplier going to be this time now? Well, the multiplier, so it decreases by 10%. So remember, that's going to be 100%, take away 10%, and that's going to be 90%. We need to turn this into a decimal. 90 divided by 100 is 0.9. So this is our multiplier of 0.9. So £1,000 times by 0.9. And this is asking us for 3 years' time. So 0.9 to the power of 3 equals, get your calculator, 1,000 times 0.9 to the power of 3. And you should get £729. So your car is devalued from £1,000 over 3 years to £729. Okay, so exactly the same formula, except instead of a percentage increase, we're talking about percentage decreases now. Okay, one more example. So a £12,000 car depreciates, remember, that means decreases, by 35% every year. What will the car be worth in 5 years' time? Again, one more time, right in the formula. So that's the original amount multiplied by our multiplier. We need to find the multiplier every time. And it's to the power of number of years. Get that box in. Nice. So our original amount is £12,000. Plug in the numbers, £12,000. Multiplied. What is our multiplier? Don't rush into it. Work it out. Multiplier. So our car value is decreasing by 35% every year. So that's going to be the original amount, which is 100%. We're going to decrease that by 35%. 100 take away 35. And that is going to be equal to 65%. Change that to a decimal, divided by 100. Our multiplier will be 0.65. That's our multiplier. So to finish off the equation, 12,000 times by 0.65. How many years are we doing it for? We're doing this for 5 years. 0.65 to the power of 5 equals, get your calculator out, 12,000 times 0.65 to the power of 5. And you will get a whopping value of £1,392.35. Okay, because this is money, it's always to 2 decimal places. Okay, so there was a rounding, you did have to round that last digit up to 5. Okay, so there you go. So that's how you calculate repeated percentage increases and repeated percentage decreases. Okay, so here's your main task coming up. So here's your main task now. So just remember, double check each question to make sure if it's an increase or decrease. And for this question here, it's slightly different. Okay, so have a double think a little bit extra hard for that last question. Okay, the wording is slightly different. Okay, so pause the video, have a go with these questions. Best of luck. Okay, and here are the answers. So hopefully you got all those right. For question D, the key word that it was monthly interest. So the amount increased by 2.5% every month. And because there's 12 months in a year, all you had to do was £125 times 1.025 to the power of 12. Okay, so it's slightly different wording there. Okay, so well done if you got those right. And let's have a look at the checking question now. So 5 years ago, Tom put some money in his bank account. Okay, we're going to call this X. I'll give you a little hint. We're going to call this X amount of money. His savings account had a 35% annual interest rate and now has £1,793.61 in it. How much money did he put in his account 5 years ago? Okay, so pause the video. See if you can find out how much money he originally put into his account. Okay, best of luck. Okay, so if we think about our original formula that we were working with, it's original amount, I'm just going to say original, times multiplier, to the power of number of years, and that will equal your final amount. Yep, final amount. Okay, so what numbers do we know from this formula? Well, we don't know the original because that's what we're trying to find. So let's call that X. So X multiplied by the multiplier. Well, it's an increase of 35%. So the multiplier is going to be 1.35. Let's do that a bit better. And this money was in the bank account for 5 years. So put it to the power of 5. And this is equal to, because we know the amount he has in his bank account at the end is £1,793.61. Okay, now how can we rearrange this equation so that we find out what X is? Well, all we need to do, if we're looking to get X on its own, all we need to do is to divide both sides by 1.35 to the power of 5. Okay, and if we do that, the 1.35 to the power of 5 disappears from the left side of the equation. So we've got X equals, and then on the right-hand side of the equation, £1,793.61, we're going to divide that by 1.35 to the power of 5. And that is equal to, tell you what, we'll do it below. That is equal to, simply get your calculators out, 1793.61 divided by 1.35 to the power of 5. And you would get, well, you would get £399. Well, you would get £399.99. 399.999. If we round that to 2 decimal places, because that's what we do with me, that would be £400. Okay, so that's to 2 decimal places. It'd be £400 and 00 pence because it's to 2 decimal places. Okay, so it's a little cheeky there with the final answer, but yep. So hopefully you got £400 there, no extra pennies, and not £399.99. Okay, the answer is just £400. Okay, so well done if you got that right, and we'll see you for the next revision lesson. Bye now.